let's try to solve this question here. What frequency will be heard by a moving observer traveling at 25 meters per second towards a stationary siren that emits a sound of frequency 280 Hz? Okay, before I try to tackle the question, let's try to understand the situation first, as usual. So let me sketch a ground. Okay, where I have a stationary siren. Okay, I don't know how should a siren looks like. Maybe something like a loudspeaker, both ends. Maybe, okay, looks like a light stick. Okay, so right now it's emitting sound. Okay, of frequency 280 Hz. Okay, probably siren should emit at both ends, right? Okay, so 280 Hz sound is being emitted. So this is the sound produced by the sound source. So we can label it as frequency is equals to 280 Hz. Then they say that you have an observer traveling at 25 meters per second. So let's imagine someone riding a car. Okay, a car over here. Maybe they have a detector. Okay, a detector looks like a microphone, so let's put a microphone in front. Okay, so this is a car with a microphone attached in front, and it's moving at 25 meters per second towards the stationary siren. Okay, this siren is stationary, so I'll label it as 0 meters per second to show that it's not moving. So because the sound source here, okay, that's very clear. The observer here is the car. Okay, then the sound source here is the siren. So the siren is stationary, so V of the source is equals to 0, whereas the V of the observer is equals to 25 meters per second. Okay, observer is the one that is hearing the sound. The one hearing the sound is moving, so our observer has a speed of 25 meters per second. Who is producing the sound? The siren is producing the sound. So the siren is not moving, that's why the speed of the sound source is equal to 0 meters per second. Okay, then after that they give the V of sound is equal to 343 meters per second. That is the speed of the sound traveling in air. In air, our sound here is traveling outwards and is traveling with V of sound equals to 343 meters per second. Okay, so if you refer to the lecture video, we already learned that the equation should look something like this, where you have your apparent frequency Fa is equals to, then you have a fraction with V observer, V sound source, then you have plus minus, and you have your frequency of the sound produced by the sound source. This is the equation. But if you refer to the video, I tell you my method of using this equation, because usually books they will say plus means you are moving towards, negative moving away, and then there's sound source, then they have different ways of classifying things. My way of doing things is just I reverse engineer it. Okay, what do I mean by reverse engineer it? First thing first, I determine which thing is stationary. Okay, so I know that the source is stationary. Okay, because I know that my source is stationary, therefore I know that Vs is equals to 0. So because Vs is equal to 0, now my equation has been simplified once. It will become V plus minus Vo, but V down there, because my Vs has changed to 0. So this is my equation, which is slightly simplified. Next, I check whether the distance is increasing or increasing. The distance between the observer and the sound source. In this case, the observer is moving towards the sound source. Towards the sound source means by the distance between the two objects will get smaller and smaller and smaller. Because the observer is moving towards it, the distance will decrease. Okay, if the distance is decreasing, then we know that the result will show that the apparent frequency must be greater than the frequency produced by the sound source. Okay, this is true for any case. Okay, if your distance is increasing, distance between the observer and the sound source is increasing, then your apparent frequency will be less than the frequency produced by the sound source. In this case, this is the situation we are facing. So we know that FA must be greater than F. How to make FA greater than F? You have to make this bracket here to be having a value larger than 1. I mean, inside this bracket, if you calculate it, the value must be larger than 1. Then only you multiply by F, you get a value of FA which is larger than F. Okay? If you're not so sure what I'm trying to say here, you can refer back to the lecture video. But in essence, what we're trying to do is making this bracket having a value that is larger than 1. Okay, how do you make a value larger than 1? Well, you have your numerator, you have your denominator. You cannot do much to the denominator because there's only one term and this term is 343 already. What you can manipulate is a plus minus over here. How do you make this bracket have a value greater than 1? You have to make the numerator larger than the denominator, right? Numerator larger than denominator, only the fraction will become a value greater than 1. So to make the numerator larger, you have to plus. Instead of minus, you have to choose plus to make the numerator larger than the denominator. So from here, I reverse engineered. I know that my equation will somehow have to be a plus in order to make the numerator larger than the denominator. Okay, so once I'm clear with it already, I can plug in my value into the equation. So V plus VO over V, that will be multiplying with my frequency produced by the sound source. 343 plus 25, 343 multiplied by the frequency of the sound source, which is 280 Hertz. This one is by the sound source, by the sound source, produced by sound source. It's very clearly. Whereas this one, it's observed by observer. So we call it as apparent because this is what is apparent, what is observed. Okay, so if you calculate it, I believe you'll get an answer of 300.41 Hertz. That means by throughout this journey of the car moving from far away towards the siren, it will hear a siren with a pitch that is higher than what is being produced by the siren. Okay, if the siren is producing a sound of the observer in the car will be listening a higher pitch, which is a higher pitch. It doesn't mean by the pitch is getting higher and higher. The pitch is higher than what is produced by the sound source, but it's a higher constant pitch. It's not changing. It's higher than the pitch produced by the siren, but it is a constant pitch. It's not getting more and more sharper. It's the same sharp. It's the same pitch, just higher than the frequency produced by the siren. Okay, that's it for this question. Thank you very much.